Welcome back to Logical Thinking, and today we're going to talk about the two most famous types of deductive arguments, which are Modus Ponens and Modus Tollens. They're closely related but slightly different, and understanding these will help you with your proofs in math and help you construct better arguments. These form the first two out of the 5 deductive forms we're going to be talking about. So Modus Ponens is perhaps the most famous type of argument, and it's written symbolically like this. Premise 1, A implies B. Premise 2, A. And our conclusion is therefore B. This is kind of like saying, if we look at premise 1, if domino A falls, B will fall. This is a sort of hypothetical. It tells us how A and B are logically connected, but nothing really about A. Premise 2 is what tells us that domino A falls. It's saying A is true, or just A. And lastly, we can conclude from there B, because once again, we connected A and B logically with premise 1, and then premise 2 told us something about A that allowed us, with premise 1, to conclude something about B. Here's an example. Let A be the proposition that there are more than 5 miles per hour winds, and B be the proposition that Project 305 in King's Dominion is closed. Premise 1 is like saying, if there are more than 5 miles per hour winds, then Project 305 will be closed. Premise 2 says there are more than 5 miles per hour winds, so therefore we can conclude that Project 305 will be closed. Now let's ask, does our conclusion follow from premise 1 and premise 2? For instance, if we take the conjunction of premise 1 and premise 2, does our conclusion logically follow and we have a valid form of argument? Well, let's see. One of the ways we can do this is to look at the truth table of A and B. Now this may seem a bit weird because we want to show that B is true. However, what we're going to do is look at all possible values for A and B and then consider those in the context of what is true from our premises and show that the conclusion logically follows. We're going to rule out all the other options. So let's go ahead and form our truth table. We're going to have A and B, and then we're going to have A implies B, which is premise 1. So we need to fill out our truth table by putting in all the possible values of A and B. There are 2 values that A can take, true or false, and 2 values of B for each value of A, true and false. So we need 4 rows. And let's first start by filling out that conditional here. So A implies B is true when the antecedent, meaning A, is false. This is the sort of vacuously true case. So I'm going to put T with a star in it. Once again, this isn't some special version of true. It's just kind of the uninteresting case. Now let's look at A and B taken together. When A and B are both true, then A implies B is true. So we're going to put a true in that row of the truth table. And likewise, when our antecedent, meaning A, is true, but our consequent B is false, then we have a clear example to the contrary. So we're going to put false in our truth table. So now let's go ahead and see whether or not our conclusion logically follows. So we're going to use the truth table to do this. Let's first look at premise 1. We're going to require premise 1 to be true, so let's look at where A implies B. Well, it's true everywhere except for this second row, so let's cross this out. Remember that P1 and P2 here at the bottom means that neither P1 or P2 can be false. This is from De Morgan's law. So we can cross out each row when each premise is false. So we're going to cross that out. And now let's look at our second premise. So our second premise tells us that A must be true. So any of the cases where A is false, we're going to cross those out as well. So that's rows 3 and 4. So let's go ahead and X them out. And we have 1 row of our truth table remaining, and it's this one. And sure enough, this does correspond to when B is true, meaning that if both premises are true, the conclusion must be true as well. We've eliminated all possibilities where B are false from our assumptions or from our premises. As a result, we can conclude that Modus Ponens is a valid form of argumentation. So this is a valid deductive argument, meaning if someone has an issue with Project 305 being closed today and still wants to affirm the rules of logic, they're going to have to doubt either one of the 2 premises or swallow their pride and admit that the conclusion is true. It's helpful to look at arguments this way because there are 2 ways an argument can fail. Arguments can fail because the premises are false, or they can fail because even if the premises are or would be true, the conclusion does not logically follow from the premises, and thus the structure itself is invalid. This is a distinction between the structure of the argument and the content, and when studying logic and doing proofs, we need to ensure that the structure is valid and the premises are true. If these premises are given to us or there's something we can assume, then all we need to do is find a logical path from the premises we start with to the conclusion we wish to get to. Think about dominoes again. We simply need to arrange our premises in such a way that we can get our conclusion domino to fall if we know the premises do or the premises are true. This is the basis of logical argumentation. Now let's look at another example, Modus Tollens, which is pretty closely related. It's written symbolically like this. A implies B. Premise 2, not B, or B is false, and our conclusion is therefore not A, or A is false. It's kind of like saying, look, If domino A falls, then B will fall. We know domino B doesn't fall, so therefore we can conclude that domino A didn't fall either. Here's another example. Let A be the proposition there are more than 5 miles per hour winds as before, and B be the proposition that Project 305 is closed. Premise 1 is like saying, if there are more than 5 miles per hour winds, then Project 305 will be closed, same as before. Premise 2 is like saying, but Project 305 is open, it's not closed. This is the negation of B. And our conclusion is, therefore, the winds are less than 5 miles per hour. Once again, we're negating that the winds are more than 5 miles per hour, so we're going to say less than or sometimes less than or equal to. And our question is, does our conclusion follow from premise 1 and premise 2, the conjunction of premise 1 and premise 2? Well, let's look at the truth table again. We're going to have A and B as before. A implies B, and I'm going to also add not B because we're going to have that as well. So I've just copied over the value for the material conditional, and let's first look at not B. We're going to fill that out. So when B is true, not B is false. When B is false, not B is true. When B is true, not B is false. So we're just flipping the values. And when B is false, not B is true. Now let's look at our premises taken together. So premise 1 tells us that A implies B. So let's cross out where A implies B is false. And sure enough, it's here in this second row. So we're going to X this out. Now let's look at our second premise, which is not B. So we need to cross out where not B is false. So that's the first row and the third row. So let's go ahead and cross those out. And as before, we're left with just one row. And if we look here, A is false, which is what we wanted to show. We wanted to show not A, which is the same thing as saying A is false. And from here, we can say that because A is false, not A is true, and we can conclude that our conclusion does indeed follow from premise 1 and 2. And as a result, Modus Tollens is also a valid form of argumentation. As an aside, Modus Tollens is an example of an argument type called reductio ad absurdum. If we show that a certain premise leads to a problematic conclusion or a contradiction, then the premise in that argument can't be true either. You'll see Modus Tollens and other related kinds of reasoning when we talk about proof by contradiction. Anyway, thanks for watching, and in the next video, we'll talk about another valid deductive argument form, the hypothetical syllogism.